Hello students, we have already studied the chapter Refraction of Light, and in that chapter we studied laws of refraction of light, and we also studied rules for the refraction of light, which explains a ray of light traveling from optically rarer medium to optically denser medium bends towards normal, whereas a ray of light traveling from optically denser medium to optically rarer medium bends away from the normal. And using these laws of refraction of light and rules for the refraction of light, we studied the refraction of light through rectangular glass block. We studied refraction of light through a prism. Now in this chapter, we are going to study refraction of light through lens. So I will tell you about the lenses, its applications and the type of lens. And later on in this chapter, we will be studying the ray diagrams, where we will first study the rules for the refraction of light, okay, and various positions of the object kept in front of the lens to obtain the image. So let's start with the definition of lens. A lens is a transparent or an optical medium. Remember, it is a transparent or an optical medium, then only refraction of light will take place. So a lens is a transparent or an optical medium bounded by curved surface, either on one side or on both sides. So at least one of the surface of the lens should be curved, or if both the surfaces are curved, then also it will be a lens. So a lens is a transparent or an optical medium bounded by curved surface, either on one side or on both sides. If I talk about the action of lens, so the lenses are used either to converge a beam of ray or to diverge a beam of ray. That means a beam of ray passing through lens can be made to converge at a point, or it can be made to diverge from a point, right? So based on these applications, the lenses are used in various optical instruments like cameras, projectors, microscopes, telescopes, and in these optical instruments, these lenses are used to form image, okay, and you must be aware that these images are also formed in our eye. So definitely there must be some lens inside our eye, right? So if I talk about the type of lens, so based on the action of lens, whether a ray of light seems to be converging or diverging, the lens can be classified as a convex lens or a concave lens. So first I'll tell you a shape of a curved surface. If I talk about this curved surface, so this shape will be convex. I hope you are aware of it. And this inward shape is called as a concave. You have to remember, the outer one is called as convex and the inner one is called as concave. And if I talk about type of lens, okay, so let's talk about type of lens, okay. So as I said, based on the action of lens, whether a ray of light converges or diverges, a lens can be classified as a convex lens or a concave lens. But how to identify this convex lens or concave lens? So concave, if I talk about convex lens, these lenses are thicker or broader at the middle and thinner, or you can say narrow at the edges. So if you have a lens and if you found out that the lenses are thicker or broader at the middle or thinner or narrow at the edges, then definitely that lens will be a convex lens, and such lenses are used to converge a beam of ray. And if you found out that if a lens is thinner at middle or narrow at middle, thinner at middle or narrow at middle and thicker at the edges. So the lens which is thinner at the middle and thicker at the edges are called as concave lens, and these lenses are used to diverge a beam of ray. So based on the number of curved surfaces present and the type of curved surface present, this convex and concave lens can be further classified into three types. So here I will take one of the surface as plane, okay, and other surface as convex, okay. And in the second case I will take one surface as concave and one surface as convex, or I can take both the surface convex. Can you see? Now in all the three lenses, you can see these lenses are thicker at the middle, you can clearly see, and thinner at the edges, so they are all convex lens. But as I said, this has one plane surface, other convex, concave, convex, both convex, so there is some name to it. So I would name this lens as plano convex lens. Plano convex lens. Here one of the surface is concave and one is convex, so it is called as concavo convex, and here both the surface are concave, so it is called as convex, so it is called as biconvex, or you can call it as a double convex. And in the same way, if I talk about concave lens, one of the surface of concave lens can be made plane, another as concave. One of the surface can be made convex, right, from the outer one, and other to be a concave, or I can make both the surface as concave. So all the three lenses, you can see these lenses are thinner at the middle and thicker at the edges, so these are concave lens, and their action will be to diverge a beam of ray. So this lens I would call it as a plano concave lens. This is convexo, this is read as convexo concave, and here since both the surface is convex, it is called as biconcave or double concave. Sometimes these lenses are also called as equiconvex or equiconcave, but there is some conditions for it. I would explain it later on. So we have studied a lens, its applications and the type of lens. So lens is a transparent or an optical medium bounded by curved surface either on one side or on both sides. And based on the action of lens, a lens can be a convex or it can be a concave. How to identify a convex lens? It is thicker at the middle and thinner at the edges, and further it is classified as plano convex, concavo convex, biconvex or double convex lens. Remember, the action of convex lens is to converge a beam of ray. If a lens is thinner at the middle and thicker at the edges, then definitely these lenses are concave lens, and these are further classified as plano concave, convexo concave, biconcave or double concave lens. Now we will study action of a lens as a set of prism. That means whenever there is a converging of a beam of ray or there is a diverging of a beam of ray, we can say this action is only because of a prism present in a lens. So I will give you some basic idea about the refraction of light through a prism, where we studied that a ray of light passing through prism always bends towards the thicker part of the prism. This is very important topic. Whenever a ray of light passing through a prism, it only bends towards the base of the prism. That means the deviation of a ray of light will always be towards the thicker part of the prism. Now I will tell you why convex lens converges a beam of ray and concave lens diverges a beam of ray. So let me tell you that if this is a convex lens and this is a concave lens. So what I am doing over here, that I will take this lens to be made up of two prism, one at the top and one at the base, and at the middle of the prism I will consider that a rectangular slab is present. Can you see it? In the same case I can say that at the top there is some prism which is kept inverted and at the bottom there is also a prism, and at the middle there is a rectangular glass block. Remember, a rectangular glass block never diverges or converges a beam of ray. So if I say some rays, if incident on the concave lens, convex lens, so this is a convex lens and this is a concave lens, and using the theory of prism of light, if a ray of light passing through a prism, then definitely this ray will bend towards the base of the prism. So this being the base, so the ray will bend down, and for this prism the base is upward, so the bending of the ray will be like this, and this ray passing through a rectangular glass block, that means if it is in perpendicular or normal, it will go undeviated. You can see the parallel beam of ray passing through convex lens seems to be converging at a point. So this converging action of convex lens is because of two prisms present inside the lens. That means this lens can be assumed to be made up of prisms and rectangular glass block. In the same way, if I talk about three rays which are incident on a concave lens, again using the theory of refraction of light through prism, we can say this ray will definitely bend towards the base of the prism which is above, this ray will travel towards the base of the prism which is below, and this ray will definitely travel undeviated. And if I trace them backward, can I say this parallel beam of ray while passing through concave lens appears to be diverging. That means here we can talk about diverging action of lens. So remember, the converging or diverging action of lens only because of an imaginary prism present at the top or at the bottom of the lens. Okay, thank you.